Okay, so which of the following is a common name for the compound H2O?
Dang, I would have said water.
Common name. That's exactly what it is. So then the answer
Yeah,
should be
none of the choices is correct. Oh,
that
okay.
is correct. Yep. Okay, so which of the following is the correct formula for the ammonium ion?
Is it the NH3
Nope.
or no? Oh, ion, huh? Ammonia.
Ion. Yep.
So it's the NH4,
It's NH4. Yep.
NH4 plus. Okay.
That's right. How many water molecules are associated with the formula unit of anhydrous cobalt perchlorate in COClO4 parentheses 2 dot 6 H2O?
Is it six?
That is correct.
Okay.
What is the name of the compound H2O and man, this is they're just giving you the easy ones first and NH3 in that order.
Okay, water ammonia.
That's right.
Um, I don't think mine is easy like this one.
Yeah. I'm like, man, that is a pretty, they're like just stacking all the easy questions up first, you know?
I know. Like, let's build up their confidence.
So let's see, it says, for each of the following names, choose the correct formula. We have neon.
Hydrogen, iodine, carbon, and fluorine.
Uh-huh.
And we have to match it to,
Either A, B, C, D,
or,
or E.
oh, okay. So would it be, wait, would it be C?
Okay, that would be incorrect
Incorrect.
because they
So,
want you to write the correct chemical
oh,
formula.
the formula.
Yep,
Oh, okay, okay. So then, let me look at this. I want to say E. Is that incorrect too?
that is incorrect.
Okay, is it A? I'm guessing already. Let me see.
Let's see. A would be correct.
A? Okay. That was my first one. I should have went with my intuition.
Yep, your first gut. Your gut tells you. Yep.
Yeah.
I'm gonna turn my camera off because I have some meat in my teeth and it's
Oh,
bothering the
no,
crap out of me. So
that's fine.
okay. Next
Mm,
question. It says, for each of the following names, choose the correct formula.
okay, hold on. Let me for each of the I can't see. Hold on.
Oh, let me scroll it up.
Okay, thank you. For each of the following names, choose the correct one. Oxide ion, silver ion, manganese, 2 ion. So it's either got to be the first one or the second one, I think.
Okay, so you said the first one or the second one.
Uh-huh.
Okay.
Just,
50-50 chance.
yeah, just because I see the 2 right there.
Okay.
And mm, I want to go with maybe the first. No, I'll go with the second one.
Okay. The correct answer is the second one.
Okay,
So,
that was a
yep.
that was, I don't know. That was a good guess,
Yep.
honestly.
Okay. It says calculate the percent mass composition. Uh, yeah, this wasn't supposed to be on here. So, but we'll do it anyway. It says
Okay.
calculate the percent mass composition of all of the elements in magnesium sulfate and display the answer in three significant figures.
Okay.
Okay. So, let me get my pencil there. Okay, so the first thing, let's write the chemical formula for magnesium sulfate.
Okay. Yeah, I should have got my.
Do you want me to pull up a periodic table?
Yeah, I was like, I don't have my periodic table on me. Ay,
Okay, so it's magnesium sulfate is
okay,
what we're doing.
there's magnesium right there. So it'd be Mg
Okay.
and sulfate.
Do you
That's
need your
sulfur.
polyatomic ion table?
Oh, let me see. Let me look for one on the online. All right, let me go look at my papers. Hold on. They're in
Okay.
my backpack. My backpack's over here in the hallway. Okay. It's polyatomic and what was it? Sulfite?
Yep. Sulfate.
Oh,
Sulfate.
sulfate. Oh, so it's SO4 2 minus, right?
Okay. That's right. So it's SO4 2 minus. And then magnesium is going to have what charge?
Oh, hold on a second. I just had that table with me. Isn't it positive? Yeah.
Positive what?
Um, 2?
Positive 2. That's right. Since it's in the second period,
Yeah.
I mean second group, it's going to be positive 2.
Yeah.
Okay. So then how many magnesiums am I going to need to balance out how many sulfates?
2.
2, are you sure?
But wait, you have to make it equal 0, don't you? Or no?
Yeah. Yeah, but this is a plus 2 and this is a minus 2. So how many of each am I going to need?
Oh my gosh. Is it 2 minus? Like
Okay,
negative 2?
so I'll say this
Yes.
again.
Hold on.
Sulfate, sulfate is a minus 2
Right.
and magnesium is a plus 2. So it has to add up to 0. So if I have a minus 2 and a plus 2, what is that going to add up to?
0.
That's going to add up to 0. So I'll need one of each one.
Oh, one of each one. Oh, okay, okay.
Does that make sense?
Yeah. That just reminded me of and I was on with Israel and I don't remember what we were working on, but he was all like, we had to balance this out. He's like, what plus negative 2 is gonna equal 0? It took me like 10 minutes to get that, that day. I was like, my brain is just fried today. I couldn't do it. I was
Yeah.
like, here we go again.
Yeah, believe me, I go through this a lot lately, especially because
Yes.
I have so many things going on. This semester has just been crazy. Like I said, too many things, too many bosses, and too many things going on.
Yeah. Okay. So,
Okay, now that we have our chemical formula, right?
uh-huh.
So then
Yes.
what we're going to do is we're going to take the mass. We're going to get the mass of the whole compound.
Okay.
So how many magnesiums do we have again?
1.
Okay. How many sulfur do we have?
1.
Okay. And how many oxygens?
Oh, wait. Is that 1 or 4? I
That's a
see
4.
4. Yeah.
So we have 4 oxygens. Okay. So then magnesium weighs, let's go to our,
Is it the 24.305?
oh crap. I closed the wrong window. Sorry.
It's okay.
Yeah, there we go. There we go. Okay. So magnesium weighs, you said 24.305.
Mm-hmm.
Okay. That over here. And we only have one, so we're gonna multiply times one, right? Which is just that number.
Oh, okay.
Sulfur weighs
It weighs 32.06.
32.06, and we're gonna multiply that by one.
By one. Okay.
Yep. And then oxygen weighs,
What is it? 15.999.
yep, 15 point,
We multiply that by 4.
that's right.
And then do we have to add them all together? Is that what we have to
That
do?
is correct. Yep.
Oh, okay.
Okay.
Let me see. So 24.305. Oh, no, wait. We did the 15. Okay, so that's 120.361.
Okay, so you said altogether,
It's 120.361.
six. Okay, so now this is gonna be our total, the total atomic mass. Okay,
Okay.
and that's gonna be for the compound. Now for each one, what you're gonna do, you're going to divide them by the total. So it's the specific element divided by total
Okay.
atomic mass.
Element divided by total atomic.
Okay, and then you're going to multiply that times 100 because it's percentage. Okay,
Okay.
so for magnesium, we're going to have 24
Mm-hmm.
point
305.
305.
And then we divide that by 120.36.
Yep.
1 times 100.
Yep.
120. Okay, so that's going to be
26 figs. So that's, you got 20 point.
19.
So if it's three significant figures, it's 20.2.
2, 3. Oh, 3. Oh, yeah, I was thinking 6 for some reason. Yeah, 20.2. Yeah.
Okay. And so and then we have the next one, it's going to be, I'm going to put it over here.
And that would be percent,
Yeah,
right?
that would be percent magnesium,
Okay.
Mg. And so then we have 32.06 divided by
120.361 times 100. Check that. 32.06. And that's 26.6%.
I'm going to go ahead and erase this magnesium here.
Okay.
Okay, and then we have our oxygens. So do you get,
Is it 0.53?
okay, so first off, we have at top, it'll be it'll be 63.996, right?
Yeah,
On top. Okay, and we're dividing that by 120,
right. 120.361.
361,
Oh, I forgot to multiply by 100.
yep, times 100.
Okay, so then it's 53.2%.
And that should add up to a total of 100% altogether. We add them together, so the 53% plus 29.6% plus 20.2%. So that should add up to 100.
100. Oh, okay.
Okay, so that's it. So that would be your oxygen. That's your percent oxygen. That's your percent sulfur. And that would be your percent
That's,
maximal. Yep.
magnesium. Oh, okay. This is not that bad.
Yep.
And that was to find the mass,
Yep. It's called percent mass.
percent mass.
Yep. Okay.
Okay.
So
All
number
right.
7.
Okay.
Okay. So which of the following is better classified as organic compounds than an inorganic compound?
Um, Organic compound means like it's naturally
Mhm.
existing.
Nope. Organic means that it has carbon in it.
Oh, it has carbon. Oh, yeah, that's right. The organic chemistry is for carbon.
Yep.
Oh, so then it'd be the last one, the
Yep.
CH4.
That's correct.
I forgot about that. Carbon.
Yep.
All right.
Okay. So which of the following is considered to be a region of electron density for the purpose of establishing electron pair and molecular geometries around the central atom within a molecule?
Which of the following is considered to be a region of electron density for purposes of establishing single the single bond? Well, wait, hold on. For
Which of the
establish
following is considered to be a region of the electron density for the
establish
purpose of establishing electron pair
around a molecule.
and molecular geometry around
Oh, molecule. Wouldn't it be 1, 2, and 3?
1, 2, and 3. Yes.
Yeah.
Yes, it's the sharing, it's the bonding, right? So
Yeah, the
sharing.
bonding. Yeah.
Okay, so which of the following would be the best Lewis dot structure for CH3Br?
Mm, oh, I could barely see those dots. Hold on.
What do we say about carbon? Carbon's a what?
Carbon's always in the middle.
In the middle.
So it's either going to be the first one or the second one.
Okay.
And I want to go with, wait, 2, 4, 6, 8. 2, 2, and 2, 4, 6, 8. How many does B? What's BR? Bromine?
Mm-hmm.
Where is that on the table?
The periodic table.
Uh-huh. I'm looking for it. Hold on. Oh, it's over here. It has 7.
It has 7. Yep. 7 valence electrons. That's right.
And then um
Hydrogen has how many?
it has 2, right?
Okay, so
Oh,
what
no,
we have 3 hydrogen.
we
It
got
does it
3.
have 2? Yeah. So it has 3, right?
Yeah.
Altogether.
Yeah.
Okay. So we have 3. And then carbon,
Carbon has 6.
are you sure?
What, valence electrons?
Valence
Oh,
electron.
4. 4. I was thinking of oxygen. Sorry.
Yep. Okay. So we know that hydrogen has 1, but we have 3 hydrogens. So altogether, we're working with a total of 14 electrons.
14. Yeah.
Yep. Now,
Okay.
who has to be in the middle?
Carbon. Sorry.
Carbon has to be in the middle. Put our 4 around carbon.
Mm-hmm.
And then
The
we know
brom.
that bromine has
The brom.
7. Yep.
Yeah.
And 7.
Mm-hmm.
That's going to form a bond here.
Bond. Yeah.
Okay. Then we have how many hydrogens?
I think it was it 3?
That's
Yeah.
right. And they each have 1.
Mm-hmm.
There you go.
Okay. So it is the one with the 1, 2, 3, 4, 5, 6.
Yep.
Okay.
So that would be number 2, right?
Second one. Yeah.
Yep. Come on. Come on. All right. Okay, there you go.
Okay.
15th time is the charm. Okay. So which of the following which of the following is the best Lewis diagram for PCl3?
3. Oh, I need to go back to that periodic table here.
This. Okay. So how many valence electrons does P have? Phosphorus.
5.
5. Okay. And then what about my chlorines?
7. So times
So
3. Was
3.
it 3? Huh. 21.
Yep, 21. Yep.
Just the 5. 26 total.
So 26 electrons to work with.
Yes.
So you said Cl, I mean, we have Cl and we have P. Who do you think is going to be in the middle?
Um, I think the P.
Okay, P is going to be in the middle,
Yeah.
and it has 5, 2 down at the bottom,
Okay.
and 1 on top. Okay, and then we
Okay.
say Cl has 7. It needs 8 to reach its octet. So that's 1, 2, 3, 4, 5, 6, and then here we'll make a bond.
A bond.
Okay.
Okay.
And then same thing up here.
Okay.
Oops, we got too many. Hold on.
Okay.
And then,
The phosphorus is gonna have a lone pair?
nope.
No?
Oh yeah, it will have a lone pair, one lone
Right.
pair. Right.
Yeah.
Yep. Sorry. And then we have one more bond, right?
Yeah, one more. The others, yeah. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Okay. I think it's good like that, right? They all have 8.
Yep, that's right. They need to obey the octet rule. That's correct. Okay, so well, it's not that first one.
Yeah, not the second one. Oh, that last one. Yeah.
Yeah, we just gotta flip it.
Yeah, I flip it around. Yeah.
Okay, which of the following compound is a hydrocarbon? Hydrocarbon.
So There has to be hydrogen in it.
It's like hydrogen and carbon, right?
Yeah.
Has hydrogen and carbon in it.
Yep. And almost all of them do.
But we're talking about only a hydrocarbon, right?
Oh, only a hydrocarbon? Oh, so
Yeah,
then
when it
the
says,
third one.
yeah, they're all organic except for this one. This one isn't organic, but all the other ones are organic because they all have carbon in them. This one has
Okay.
carbon in it, but carbon dioxide is not considered to be an organic compound. It's
Okay.
okay. Which of the following best describe a polar molecule?
One with atoms having the same electronegativities, one with asymmetrical distribution of charge. Okay, without charge, one with one has two or more hydrogen. Would it be the second one?
That is correct.
Yeah.
Yep, the one with asymmetrical distribution of charge. We know when it's polar, one side is partially positive, the other side is
Yeah.
partial. Yep.
Negative.
Okay. Given the following electronegativities, arrange the bonds according to increasing polarity. So we're going from the lowest to the highest.
And those words always confuse me. Okay, increasing.
Yeah, remember Pac-Man or the alligator eats the bigger one. That's how I remember it. So
Okay.
yeah, so since you have the do this, how you get
Yeah. I got you.
okay, so like this, right? There
Uh-huh.
we go, like that. So then the alligator eats the bigger one. So
Okay.
it always points to the one that's going to eat.
Okay, arrange the bonds according to the polarity. Um, the highest is 5.0 and like the polarity, the electronegativity.
Hmm. So we're looking at electronegativity.
So
Remember how
then
we do it?
it'd
Remember,
be
take the difference of the two, right? And then that'll let us know which one is more polar, right? So you take the difference between the two. So in this case, let's say we have hydrogen and fluorine, right?
uh-huh.
H and F. So you take the one that has a bigger number. So that's
Okay.
4.0 minus 2.1,
2.1. Yes.
1.9.
Okay.
Okay. Then we'll take, let's see, we have hydrogen and chlorine.
Okay.
Okay. So then that's
3
3.
points
Yep.
minus 2.1. About 2.9.
Does that equal 0.9?
Okay, point 0.9. I was like, what is that? I need my calculator for all this math.
Okay. And then we have chlorine and carbon.
Carbon.
Yep. So CCl. Chlorine is 3.0.
Minus 2.5.
2.5. Yep.
That's 0.5.
Okay.
And then
And then we have, what was the other one? Hydrocarbon.
hydrogen and carbon, right?
Yep. Okay. So we have 2.5.
Minus 2.1. That's 2.4.
It's going to be 0.4.
Oh, yeah.
Okay. So we know that this one will be our lowest. So it's
Uh-huh.
going to be H
C.
and then,
And then it'll be the CCl, right?
yep, CCl. Yep.
And then the HCl. And then HF. Okay.
So that would be,
Where is it? The third one?
that's correct. Okay,
Thank you for that refresher.
no worries.
How does a phosphorus atom achieve an octet of electron? Where is it at?
Oh, you're ahead of the
What?
number 15.
Oh, sorry.
Similar question as the last one. So
Okay. Arrange the following bonds in order of increasing polarity. Oh, so we have to do the same thing? Okay.
yep.
So C equals 2.5.
So 2.5 minus 2.1.
Mm-hmm. 0.4.
Okay.
And then
CAS. 2.5
wait,
minus
how do you know which one to like align it? Like, oh, because in the
in the
things
order.
it has a C, huh?
Yep.
Oh, okay, for all of them. Okay.
Then we have what? CS.
Yeah, that would be the next one. CPCSCS minus 2.5, 0.
And then
C and
CS.
SC.
Yep.
0.1. BCSC.
Is that right? SC.
See,
Oh, not 2.5. It's 2.4. Sorry, my bad.
oh yeah, it's okay. Yeah, it's 0.1, right?
Yep.
Okay. C, so CS,
Oops.
CSC, and CP, and CAS. So I think it's the last one, right?
Yep, that's right.
Okay.
Okay. The next one.
Um, how does a phosphorus atom achieve an octet of electron? It has to gain 3 electrons, right?
Good job. How many single bonds, or sorry, how many single, double, and triple bonds are there in the following molecule?
There's 1, 2, 3, 4, 5, 6, 7, 7 single bonds. And then, wait, 1, 2, 3,
That's
4,
right.
6. And then one double and then one triple. So yeah, 7, 11.
That's right. So which of the following has slash have the electron configuration N,
Mhm.
3s2, 3p6?
Okay. Ne,
Okay, so
so
let's get our periodic table.
sulfur, yeah.
So Ne, what was it? Let's see, I forgot. Let me write that.
3s2 and 3p6.
Okay. Okay, Ne, and then 3s2, so that would be this one, and then 3p6. That's 1, 2,
3,
3,
4,
4,
5,
5.
6.
Okay,
Argon.
so it's going to be like argon. Okay,
Yeah.
so we're looking for things that are going to be like argon.
Oh, like argon. Oh, yeah, that makes sense. Yeah, because argon is already.
That's right. Okay, so here, so we know argon is going to be good.
Mm-hmm.
Okay, and then let's see. If we have S and we add 2 more electrons, that's going to be like argon.
Uh-huh.
Okay, so then that one is going to be like argon. What about just Cl with no
Chlorine.
charge to it? Cl, here's Cl. So hey, we need a 1, -1, but it doesn't have a -1,
Oh, okay.
so we know that that one isn't,
Okay.
right?
Yeah.
Put an X there. And then K plus, so let's go to our periodic table. K, and then if we lose 1, that'll be just like argon.
Oh, yeah.
And then Ca2 plus. Ca, and then 1, 2. That'll be
Two.
just, yep.
Mhm. Wow.
Okay. So then it's 1, 3, 4, and 5.
Yeah. Okay.
Okay.
It's okay. Which of these are both isoelectronic with noble gas atoms? What is isoelectronic? Both of which
It means it has the same number of electrons. So kind of like what we did with the other ones with the K and the Ca2, K plus and the Ca2 being isoelectronic to argon. It just means same number of electrons. Okay.
okay.
So let's see. I'm going to do this. Put this right next to each other. Then make it a little smaller.
Okay.
Okay. So we have SC3 plus. So SC is right here. And if we go 3 plus, so that's 1, 2, 3.
Argon.
Okay. So ooh, I skipped the first one. Didn't even pay any attention to it.
Oh,
So that's
it's
going to be just like argon. Yep.
yeah.
And Cl minus is also going to be just like argon, right? So
Okay.
those are going to be the same, right? So that
Uh-huh.
one good so far.
Oh, okay.
Yeah.
Uh-huh.
And then so we had Fe2 plus, so Fe, and then if we lose 2 plus, so that's 1, 2. So it's going to be chromium, right? And then
Mhm.
we have S2 plus, 1, 2. So that's argon. So those are not the same. So
No.
no good. Okay. We have calcium and hydrogen. They're in two total different things. So yeah,
Yeah.
they're going to be the same. So, and then we have silver and phosphorus, which is again is up here. So
Yeah.
the number is not going to be the
Oh,
same. Yep. And
oh,
then
that iron and iron.
yeah. So in that case, we have iron. That would be 1, 2, and then 1, 2, 3. So one would look like palladium, and then one will look like I'm
Oh,
sorry, vanadium and chromium. Yep. So then we know that that one is incorrect.
so
So
it's SC.
yep. So it would be the second one.
Okay.
Yep. Funny, it's only almost 6, and then I'm like exhausted. Uh,
Wake up so early, huh?
I do, I do. Yeah, this
Uh,
morning I got up at 5:30, and I slept in. I usually get up at 4.
yeah,
Uh,
I know you usually wake up like about 4 or 4:30. I hear
yeah,
you say that. I'm like, oh my gosh.
yeah,
I think I went to sleep like at 3:30.
yeah.
Oh
And
man.
I get home so late. I get home at around midnight because I go charge my car and then I go home. Yeah.
Wow, you had
So the
long
week,
days.
yeah. Like I said, this semester there's so much stuff going on. You
Mhm.
know, it's funny because they were like, "Oh, we're not going to give them any classes on Tuesdays and Thursdays, but we'll put all the meetings on those days."
Ay, ay, ay.
Yeah. Okay. So we have two natural isotopes for silver. We
Mhm.
have one that's 51.83 of the atoms have a mass of 106.90509. The
Uh-huh.
remaining fraction has a mass of 108.9047. Calculate the atomic mass of silver. Okay, so things I would do if it were me, I would get rid of the ones that I know that were just like kind of dumb answers. Well, we know the atomic mass, if we looked at our periodic table, the atomic
Mhm.
mass of silver is going to be approximately uh, silver, 107.8,
107.
right?
Mhm.
So then I figure it's going to get, you want to get rid of the ones that I know are kind of dumb answers. So this was
Oh,
a dumb answer here. This one was
yeah.
a dumb answer here, right? So
Mhm.
now we just want to calculate to make sure that it's right. And what we're going to do is we're going to multiply that 51.83 times 106.90509
Mhm. Nine.
plus the remaining fraction. So if we have 100%, subtract 51.83%. So then that's going to end up giving me 48.17%.
Okay.
Okay, so then I'm going to take that 40, oops,
And you add that to it.
yep, 48.17. And then we're going to multiply that times the 108.9049. Oops, sorry, 47. Thank you.
Mhm.
Okay, and then we're going to divide that whole thing by 100.
Okay. So, oh yeah, it's 107.87.
Yep. Okay.
Okay. Hold on.
So
Times 108.90%. Okay.
okay. It
Mhm.
says, which of the following is the correct classification for both calcium and iron? Calcium is a transition element and a metal. Iron is a transition element and a metal. B. Calcium is a transition element and a metal. Iron is a transition element and a nonmetal. C. Calcium is a main group element and a metal. Iron is a transition element and a nonmetal. D. Calcium is a main group element and a metal. Iron is a transition element and a metal. E. Calcium is a main group element and a nonmetal. Iron is a main group element and a metal.
Would it be the second to the last?
This one right here.
Yeah.
That is correct.
Okay.
Because if we look at our periodic table, we know that calcium is part of that main group.
Yeah.
And then it's a metal. And
Right.
then we know that iron is a transition metal. That is correct.
Okay.
So which of the following is correct for the element with Z equal to 9? So Z represents the atomic number. So which one is correct for the atomic number equal to 9?
Let me check. And 18.9 and two. I'm getting confused right here.
Mhm.
I'm getting confused with this two and that two.
Okay. So let's read what we're talking about, right?
Because we're looking for like
So
the
the symbol,
symbol
which is
is
going to be
F.
atomic mass. This would be
Uh-huh.
our period, and then this would be our group. Okay.
Okay.
So we know we're looking for the atomic number of 9. So we're going to go to the atomic number 9
Yeah,
on our
nine.
periodic table.
And it's fluorine.
Okay. What period is it in?
Two.
2. Which group is it in?
Um, 17?
17. Yeah.
Yeah, 17.
So it's this one because we know that this one is the US usage. So we're really just looking at that second.
Oh, okay, I think I must have got confused like with the 7A then.
Yeah. Yeah, the
Okay.
7A is for USA usage
Oh,
periodic. So you're
okay.
always going to look at that second. You're going to look at the one that's just a number, not the one that has a number and a letter.
Okay.
Even though it still doesn't want to listen to me. It's like I like, nope, we're not going to do the right one. Okay. Okay. It says, which of the following elements are correct? Correctly match with their period and group.
Okay. C is not in the first period. Wait,
Sorry, I was just trying to
it's
see.
okay. Go ahead. It's fine.
There we go.
And E is in the second period. 18. Okay, wait, again. I'm sorry. The 8A and the 18. I
Yeah, so
just looked at
just
the
just pay
18.
attention to the 18. Yeah,
The
don't worry
18.
about the 8A. So that's
Okay.
all for the American usage periodic table.
Okay.
So yeah,
So I think
we'll
that
go through
would
this.
be one because it's in the second period
Okay.
and it's in row 18, so that one's good.
Okay.
The first one, no.
Okay.
And
So we
then
know that it's not in the first period.
yeah. And then aluminum is in the third period and it's in 13. That one's good.
Okay. So aluminum is good.
And then what is that? Calcium? The next one? Huh.
Yep.
It's in the fourth. That one's not.
Oops.
That one is a no. And then
Okay.
the oh, where's the BR? Oh yeah, right here. Bromine. One, two, three, four, the fourth period, and 17. And then bromine, no. So it's just
Yep. So it's 2 and 3.
and 3. Uh-huh, yeah.
Okay.
The last one.
Okay. Looks good. Okay. The next one.
Okay, which of the following is correct for the element of the atomic number 20? 1920, calcium. It's in the calcium atomic mass is 40.07 or about 0.8. And then it's in the fourth row.
Okay. Fourth period. Okay.
Oh yeah, fourth period. Yeah. Fourth
Mhm.
period and the second group. So, oh yeah, it's that one. That second one.
That's right. So what is the empirical formula for a compound that contains 80% carbon, 20% hydrogen by mass? Okay, so we didn't go over this. I need to check to see why these are coming up, but I'll fix
Okay.
that afterwards. So the way that you would do this, right, is
Mhm.
um, you're going to make the assumption. We're going to make the assumption that we have 100% by mass, right?
Mhm. Okay.
So if we assume that we have 100 of the entire thing, so that means that this guy is going to be 80 grams
Carbon.
of carbon,
Mm-hmm.
and then this guy is going to be 20 grams
Hydrogen.
of hydrogen. Yep. Okay. So then you're going to take its molar mass and you're going to divide it by. So carbon weighs 12 grams based upon our periodic table.
Mm-hmm.
See, carbon, 12 grams roughly.
Mm-hmm.
So, and then hydrogen weighs 1 gram, right?
Okay.
So we'll go divided by 12 grams per 1 mole. And then this is going to give me my number of moles. It's going to give me quantity, right?
Okay.
So 80 divided by 12.
Let me see. It's 6.7 or how?
6.67, yeah. So
Okay.
366, so
Three.
that's what we start off with. Yeah. Moles of carbon. Okay. And then we go ahead and divide this one by 1 because it's approximately 1 gram per 1 mole. So then that's going to be 20 moles. Okay. So then of hydrogen. So then you take the one that is the biggest value and you
Mm-hmm.
divide it by the one that is the smallest value.
Oh,
So
okay.
we divide both of these by, I'm going to change my color. And this is going to be divided by 6.67. And then you're going to divide this one by 6.67.
Okay.
Okay, so this one will be 1. So this, we would have 1 carbon. And then
Mm-hmm.
this guy would be 20. So let's see.
Wait. 20.0 divided by 6.67. That's me, 2.3. It's 2.9 or
About
2.9.
2.9. Yep. Okay,
Okay.
so it's 2.9. So this is close enough that we can round up because you can only have whole numbers, right? As you
Mm.
can see, the
Yeah.
coefficient whole numbers.
Okay.
So approximately 3
Uh-huh.
for hydrogen. Okay. So then our chemical formula is going to be C, because there's one of them, and
Uh-huh.
there's H.
H3.
That's right.
Oh, that was pretty
The,
cool.
the first one.
Yeah, the first one, yeah.
Yeah, we'll be going over that tomorrow. And,
It's pretty interesting.
yeah. Yeah, the meat of it. It's like, yeah, but we had a really rough semester because I
Yeah.
missed 2 lectures. Yeah, I missed 2 lectures for your class.
Uh-huh.
Yeah, and that those 2 lectures because it's short term, it really
Mm-hmm.
impacts things. Yeah. Okay, so let's see. It says list the number of atoms for each of the elements in the formula ammonium sulfate. So we want the chemical formula for ammonium sulfate.
Ammonium sulfate.
Hmm?
Isn't that is it NH?
How many H's?
Is it 4?
That's right.
Mm-hmm.
And then we know that it has a plus charge. So it's
Uh,
normally a plus charge. Okay. And then we know sulfate because we did that one earlier. What was that?
that was SO4 oxygens and then the 2 minus.
That's right. Okay, so then how many ammoniums will I need to balance out the sulfate?
2.
Yes, I'm going to need 2 of these.
Mhm.
Okay. Okay, so my chemical formula is going to be NH4. I'm going to put that in parentheses.
Mhm. And then 2.
2. That's right. SO4. Okay,
Oh,
so that means that we have how many oxygens?
no, we have 4.
We have 4 oxygens. Okay, how many sulfurs?
1.
We have 1 sulfur, so we can get rid of this last one. You know that that's not right.
Yeah.
Okay, we have how many hydrogens?
It's is it no 4 or 8 or
It's 8.
6?
It's
It's 8.
8, remember? Because there's a total
You have
of,
to multiply.
yeah,
Yeah.
that's right. We got to multiply it. That's right.
Mhm.
So we have 8 hydrogens, right? So
Yeah.
that's our answer.
And then 2 nitrogens. Yeah.
And 2 nitrogens. That's right.
Oh, so they like break it down right there.
Yep. Okay. So the next one. How many atoms of each element are in the formula unit of ammonium phosphate? I mean,
Magne-
not a magnesium phosphate. Sorry, I'm making stuff up now.
It's all right. The magnesium. Magnesium is just the Mg, right? And it's like
That's right.
a positive charge.
That's right. Positive what?
Oh, is it in positive 1 or
Nope.
positive 2? 2.
Positive 2.
Yeah,
Group 2
2. Because
metal.
it's in
That's
the
right.
group 2. Yeah.
That's right. Plus 2 charge. Okay. And phosphate.
Mm, phosphate is gonna be PO4 3 minus.
Okay. Okay. Now, the easy way to do this, since these are not divisible by each other, right?
Uh-huh.
One of them is not 1. So
Yeah.
what we can do is we can do, I call it cross multiply. So
Oh.
kind of
So
like
you
what
just
we're
like
doing now.
switch the 3 and the 2?
That's right. That's going to be your coefficient.
Okay, yeah.
Right? So then we get Mg, and that's going to have 3.
3, yeah.
And then our PO4,
In
that's
parentheses,
going to have parentheses. That's right. And that's going to have 2.
2. Yeah.
Okay. And so then how many total magnesiums do we have?
3.
Okay. So, well, we know that these are all wrong.
Yeah.
So that
So,
makes it easy, right?
yeah. And then it's 8 oxygen and
Yep. And
2.
then you just confirm, yep, 8 oxygen and 2 phosphorus. Yep.
Okay,
Okay. Ready for the next one?
let's go.
Okay.
A compound analysis, and a compound analyzes as 18.0% carbon, 2.26% hydrogen, and 79.7% chlorine. Calculate the empirical formula of the compound.
So how do you
Okay,
think we're
it's
gonna
like
do?
that other one, right?
That's right, exactly like that other one. Yep.
Okay, so
So we're going to assume that we have 100 grams of our total compound. So that means that 18 grams is going to be carbon.
mhm. And then 2.26 grams of hydrogen and 79.7 grams of chlorine.
Okay. So we know carbon weighs 12. So that 12 at the bottom here. Grams of carbon. And we're just going to be, we're going to do the estimate rather than being so exact.
Okay.
1 mole. For the most part, it never burns you too bad. I think I
Okay.
got burnt once
Oh.
by doing that. So
Oh,
okay, and hydrogen weighs Hydrogen weighs 1 approximately.
Uh-huh.
So,
One mole and
so gram on the bottom, 1 mole on top. And then chlorine weighs 35.35.
is
I mean, so 35.45.
35.45
Yeah.
and 1 mole.
Okay. Okay, so then do that math for each of them.
I have to divide. So the 1 point, you said it has to be a whole number, right? So it's 1.5, that would be 2,
Okay.
like 2 carbons?
So the first one is 1.5.
Yeah.
So what we're going to leave for 1.5 for right now, and then we'll talk
Okay.
about that because
Okay.
it's not close enough to be 2.
To
Yeah,
round up. Okay.
that's right. So 1.5 moles of carbon. And we're also not completely done either, right?
Okay.
Okay, so then the next one it would be
2.
2.26
Mm-hmm. Yeah.
moles
Hydrogen.
of hydrogen. And then we have
That's 2.25
okay, 2.25.
moles of chlorine.
Okay, so then we take the one that has the smallest value, our 2.25, and we're going to divide it by that. So we're going to do that in,
Oh wait, isn't the smallest value 1.5?
oh, sorry, 1.5. You're right.
Yeah.
I'm glad that you're paying attention and I'm not.
It's okay. I was just like, wait a minute.
Okay, so yeah, 1.5. Yeah, we were going to really mess up. 1.5 and 1.5.
That's 1.
So that would be 1 carbon.
Oh wait, this is where we get the whole number, huh? Right here,
That's
right?
right. Yep.
Okay. Oh wait. 2.26 divided by
That's
1.5.
1.49.
Mm,
So we'll say actually it'll be
I
1.5.
got 1.5. Yeah. 1.5.
And then the next one will be 1.5, approximately 2, right?
Okay.
So, okay. So now these two are going to be about 1.5, right?
Mm-hmm.
So now the goal is that we have to try to get a whole number, right?
Right.
And
Mm-hmm.
so, and these guys are not close enough that you can round up. So if it was like 1.9, we could round up. But
Yeah.
since it's 1.5, we need to figure out what can we multiply these guys so that they would give us a whole number. So 1.5 times what is going to give me a whole number?
1.5, no? Or 0.5?
Multiply. Think about multiply, not add.
Oh, um, do I have to do this math right now?
Yeah, you got to do the math right now. So,
Okay, okay. Let me,
so
let me.
when, yeah, so the easy way to think about it is that, okay, if I have 0.5, what times 0.5 will give me a whole number? What times 1.5 will give me a 1?
Oh, well, yeah, wouldn't 0.5? Oh, no, that's multiplying. I'm thinking of
Yeah,
addition. I keep on thinking of an
yeah,
addition.
yeah. So if I have 50 cents, how can I get a dollar? How many? What do I need?
50 more cents.
So then that's how many? 50 cents.
Oh, 2.
Two.
Yeah,
Okay.
there you go.
So we're going to multiply this times 2, and then we multiply everything by that same value.
You understand money, huh?
Oh, yeah. Yeah. When you say money, you get it real quick, don't you? Yeah. Okay. So then in that case, then we have 2 times 1.5. I mean, and that would be 3. So we have
Okay.
3 CLs,
Uh-huh.
and then we have 3 hydrogens, and then we have 2 carbons. Okay. So we're looking for something that is 2 3, 3.
2, 3, 3. Let me see.
So 2 carbons and 3
What's the last
hydrogens.
one? Yeah.
Trying to get the button to press.
Oh.
Yep.
Okay.
That's our answer.
Okay.
I'll let you get that down. So yeah. So anytime that you have like 0.5, and I'll give you a little key, and you can write down. I'll give you guys a message. You guys are allowed to use. I'll give you guys a page, the front page, as a little cheat sheet. So
Mm-hmm.
for this next exam.
Okay. Thank you.
So my little table is if you have anything that ends with 0.2, that's going to be, you're going to multiply it times 5.
Oh,
Anything that ends with 0.33 or 0.3, you're going to multiply that times, so that will be 2/3. You're going to multiply that times 3. Forgot 1. Hold on. And if you have 0.25, you're going to multiply that times 4. And if you have 0.5, you're going to multiply that times. Hey, how are you? 0.4? Yeah, 0.4. You're going to multiply that times. What am I going to multiply 0.4 by? I used to know this at the top of my
you
head,
did?
and I can't right now. So
It would be what? 50, 60, 70. Would it be by 6? No.
it's actually 2.5, but we don't want to do that. So we'll say 0.5. There we go. 0.5 times
Uh-huh.
2. There you go. And then we have 0.67. That's going to be multiplied by 3. And then we have 0.75. And that's going to be multiplied times 4. You see the trend?
What is the trend? I see 5, 4, 3, 2, 3. What is it? 4. What's the trend? I don't see the trend. In the
Okay.
first number, you mean? Or in the
No,
second?
in the second number.
In the second number? -1, -1, -1. And then it goes up 1, up 1, up 1. Yeah, huh?
Yep. Yep. So like this one, yeah, it goes down and then it comes back up.
And then it goes up.
Yep.
It's like the.
Yeah. So if you end up with something that has 0.8, like one of the numbers are 0.8 after you do the division, like this
Mm-hmm.
one was 0.5. So we multiply that by 2.
Yeah.
Okay. And so, if this was like
1.8.
0.33 or
Uh-huh.
0.8, yeah, if it was 0.8, then we multiply it by 5.
Yeah.
Right.
Okay.
Yep. Okay.
All right.
Okay. So number 30 is just like number 29. You to do it again.
Okay.
And so,
Uh-huh.
and more than likely, questions like this are going to be, um, they're going to be extra credit. Put it like that.
Okay.
They'll most likely be an extra credit question. Since we haven't really gone over it, we'll be going over it tomorrow.
Okay.
Although you've gone over it today. So
Yeah.
okay. So let me clear up. Okay, so I'll let you do this one.
A compound is composed of 74% carbon, 8.70% hydrogen, and 17.3% nitrogen. Its molar mass is 162 grams per mole. What is its molecular formula?
Okay. So I'll help you with this. So what we've done so far is called the empirical formula, which is the simplest form that we can get.
Uh-huh.
Now, the molecular formula is we have to take in consideration its molar mass, and that's what
Okay.
we'll do at the end. So if you work on that first part, then we'll work on the second part. And then I'll show you how to do the second part. So
Oh,
what is the first thing that I'm going to do?
hold on.
Percentages. What am
Percent.
I going to make the
So
assumption?
is that where we assume that we have 100%?
That's right. We have a total 100% of our compound. So then that means that how much carbon do we have?
It's 74 grams
That's right.
of carbon.
So we have 74.0 grams of carbon. Okay. How much hydrogen do we have?
We have 8.70 grams.
8.70 grams. How much nitrogen do we have?
17.3 grams of nitrogen.
Okay.
And
So,
then is this the same where we put the 1 mole on the top?
yep, that's right.
Okay. 1 mole, 1 mole.
Of carbon.
And then for
How much
carbon,
does carbon weigh?
12 grams. I already got that memorized.
12 grams.
Yeah. And then
12 grams.
hydrogen, well, the 1 gram.
That's right. 1 gram on the bottom, and
And then
then one.
nitrogen, nitrogen would be it's 14.007. Do I have to put the whole thing or can I just put 14?
You can just put 14. When it's like 0.00, then we
Yeah.
could the
Okay.
rounded number,
Round it down. Okay.
14 grams.
Okay.
It's only when you have like 0.37 or 0.82, then you're gonna have to, you can't round up that much.
Okay. 4.0 divided by 12 is 6.2 gram. No, 2 moles of carbon.
6
8.6.
points. 6.
6.2 or yeah. Wait, hold on.
Let's do 6.7, 6.17 grams. That's 3 sig figs.
Oh, yeah, yeah. Okay. 6.17. I see that.
Okay, and that's moles of carbon. That's just going to be that number. And then we have moles of hydrogen.
8.70 divided by, oh, it's just 8.7
Yep.
of carbon and 17.3. Is the second one? Well, no, huh? I was gonna say the second one always gonna be the same, but it's just because it's hydrogen, right?
That's right. Yep.
Okay. Divided by, oh, wait, what?
17.3 divided by 14.
It's a 1.2 or 1.24.
2, 4. Yeah. 3 sig figs, right?
Okay.
Yeah. Okay. So now
So now we have to divide it by the smallest value,
mhm,
and that would be 1.24, right?
okay. Oops, let's change the color so that people back at home that weren't here.
Oh, I forget that this is recorded, huh?
Yep. Yeah, I'll get Israel to put it up tonight. He's my video guy. Thank
Oh,
God.
is he?
Yeah.
I'm gonna tell him.
Yeah.
'Cause I was asking him for help for like the video.
Yeah.
I've been like, let me send everything to you and you could do it for me. Eh?
Yep.
Okay, that first one would be 4.98.
Okay. That's, you
Because
said
We stay with the three sig figs, right?
3 sig figs. That's right. Yep.
Okay.
And but it says 14. You said it's 4.98.
Well, because it says 4.975.
Okay. Yeah. So 4.98. And we can look at that. So that's a 9. So that's really close. And plus
So
9.
5.
So that's approximately 5.
Yeah.
Approximately 5 carbon. Okay.
And
And
then
then
that's 8.7 divided by 1.24. That's 7.01 or 7.02.
okay. So we can say approximately
7.
7. Okay.
And then that would just be 1, right?
Yep. Okay. So our chemical formula should be
C4,
C5,
H7, N.
H7, and N, right? So this would be our empirical formula, right? So
Okay.
to get our molar mass, we're gonna have to use this here. So
Uh-huh.
we know that carbon weighs 12, so 5 times 12. 5 times 12 is 60. Okay. And then hydrogen weighs 1, so it's
7.
7 times 1. So that's 7. And then nitrogen weighs
Wait, 2.
14. Yep. So that's 14. So that's a total, if we add them together. Yep. Add them together. So then that is what, 81?
Let me check. 14 plus 7 plus 60. 81, yeah.
Okay. So we take that 81, right? And so we go 162 divided by 81. We get that 162 from up here.
Yeah.
And so that would be 2, right?
Okay.
Okay. So then what we'll do is we'll multiply the
All of
coefficient
those by
by 2.
2?
Yep.
Okay.
E10, H14, N2. And so that would be the molecular formula.
Oh, okay.
So when they ask for the molecular formula and they give you the molar mass, then you you have to do this part at the end.
Oh, not bad. Okay. So which one is it? C10. Oh, yeah, that last one.
Okay, so it says from the following, pick those that are not empirical formulas. Remember, empirical formula means that they're the simplest form. In other
Mm-hmm.
words, they can't be divided by a number. Both of the, or in this case, both of the elements can't be divided by a number, another number. So like for instance, this very first one, this would not be an empirical formula because they can both be divided by 2.
Oh, so it'd be like the C7H6, huh? Oh,
That's
no,
right.
no, no. Yeah.
Yep.
Oh,
Okay, so you said, so
oh,
the ones
wait.
that so we're looking for the ones that are not empirical formulas. So
Yeah.
that very first one isn't an empirical formula. So
No.
that one isn't. So we're going to go ahead and circle that one because they're both divided by 2. What
Right.
about the second one? Is that an empirical formula?
Um,
There's 2 and 3.
I know, that's why I'm confused. The 2, I want to say yeah, but the 3,
But can you divide 3 by 2 and get
no,
a whole number? So then no, we can't.
no. Okay.
That's an empirical formula, right? So that one would be an empirical formula. What about this one? There's 6 and 6. What am I going to divide that by? So that
By 2 or 3.
or 3 or 6, right?
Yeah. Uh-huh.
Yeah. So we could divide it by 6 because they're both divisible by 6.
Uh-huh.
So then that one isn't an empirical formula.
Okay.
The next one,
Is 7 and 6. That one is, right?
it is an empirical formula. That's
Yeah.
right. So anytime that you have, typically the telltale signs is
Mm,
if you have what are they called? Prime numbers.
the
Right?
prime, yeah.
Yeah, if you have prime numbers, then that's going to give you an empirical formula.
Okay.
Okay. What about number 5?
What is it? It's a 7 and
7 and 21. What can
Be-
I divide both of those numbers
Yeah, by 7, by 3,
by
by
7?
7.
That's right. So then that one isn't, right? So
Uh-huh.
then it's 1, 3, and 5.
5. Okay.
Okay. So then that would be,
And to the last one.
yep.
I mean the second to the last, yeah.
Okay. Let's go to the next one. It says we have 40, so we got about 8 more left. So it says ammonia is formed from its elements. Write the balance chemical equation for this reaction. What is the sum of the coefficients? Oh, we have ammonia is formed from its element. What is the chemical formula for ammonia?
NH4.
NH. Not
Oh,
ammonia.
wait. Oh, is it NH3?
NH3. NH3. And it says it's formed from its elements. So if it's being formed, that's going to be the product. And so what are the elements?
Nitrogen and hydrogen.
Okay, so what is the chemical formula for nitrogen?
N.
And what? There
What
should be
is
a
it?
number.
Hold on.
Have no fear of ice cold
Oh,
beer.
dear. I remember that, but what does it mean? I always forget that one.
Diatomics.
What
It's
was
a
that?
diatomic. What does di mean? Diatomic.
Oh, it's 2.
Yeah. And then we know that hydrogen is also diatomic.
Another 2.
Okay, so now we need to balance the chemical equation.
Okay.
So what should be the coefficient in front of the N? How many nitrogens do we have on our reactant side?
We have 1. I mean 2. Sorry.
And then on our product side,
We have 1.
okay. And hydrogens?
2.
Okay.
And then 3.
Okay. So what do I need to multiply to balance out the nitrogens?
The 2.
Okay, so then I put a 2 over here. So then that gives me 2 nitrogens here. Then how many hydrogens do I have?
6.
There we go. And then what do I need them?
3.
Okay. There you go.
Okay.
Okay, so now we need to add up the coefficients. And this is the thing that always gets everybody.
5.
The next part. So you have
Oh,
1,
you have 1.
yep, 3, and 2. So that's a total of
6, right?
6. That's right. And that, like I said, that's the part that always gets everybody because
Yeah.
everybody forgets that 1. Yep.
Mm-hmm.
Sneaky, sneaky. Yep.
Okay.
Okay, number 33. Magnesium is placed into sulfuric acid. Write the balanced chemical equation for the reaction. What is the sum of the coefficients? Okay, so we have magnesium. What is the chemical formula for magnesium?
It's Mg.
Okay, and then sulfuric acid.
Let me check the table. Hold on. Wait, that wasn't on the table, huh?
Nope, but it helps us if you have the polyatomic ion table. So
Okay.
if you read that side, I ate organic apples despite them being poisonous.
Uh-huh.
And let me go to that table real quick. Hold on. Okay, so if we go to that table, the IC matches up with, oh, I almost did that wrong.
The 8 with the icy?
Yep,
No.
yep,
Yeah.
that's right. 8 with the IC. There. These go together.
So would it be sulfate? Like that formula kind of?
Okay, So yeah, so it's going to be sulfate is going to be part of it. And then since it's an acid, we know sulfate has a -2 charge, right?
Uh-huh.
Oops, SO4.
Four, four, two negative, yes. Or two minus.
Yep. Okay. And then anytime you have an acid, you're basically adding H plus to balance out the charge. So how many H pluses will I need to balance out the 2 minus?
Is it two?
That's right. So my chemical formula is going to be H2SO4. And we know that for it to be an acid, it also has to be aqueous, AQ.
Okay.
So I can go ahead and erase this part here. Okay, so then here, I am going to do, it's called a single replacement reaction. We talked about that in the very, very beginning. So in this case, the magnesium is going to be replacing the
Hydrogen?
hydrogen. Then we're going to end up getting magnesium. And we know that the magnesium is a 2 plus when it forms an ion. And we know that the sulfate is a 2 minus when it forms an ion. So it's going to match up perfectly. Okay, so we'll write that over here. Mg is going to become 2 plus, and then SO4 we know is a 2 minus. So they match up perfectly.
Okay.
Perfect match. Okay, and then we're going to put aqueous, AQ, because it's still in solution.
Okay.
And so that means that we get the hydrogen by itself.
By itself.
So we know when hydrogen is by itself, it's going to be H2.
So,
And that's going to be a gas.
oh yeah.
Okay, so now we have to balance the chemical equation. I think it's already balanced.
Oh yeah. I was just looking at the at the
Okay.
product side.
So then how many coefficients do we have
One,
here?
two, three, four.
4. Okay, so that would be the sum of our coefficients is 4. Okay.
Okay.
Okay, so the next one, it's sulfuric acid neutralizes barium hydroxide. Okay, so then we have sulfuric acid, same acid that we have up here.
Mm-hmm.
We can use that.
So it's SO4.
H2SO4.
Oh, the H2. I forgot.
Yep.
Okay.
And that's AQ, because anytime you see acid, you know that it has hydrogen in the front. And that
Okay.
hydrogen has to balance out that polyatomic ion.
Okay.
Okay. Plus, we have barium hydroxide.
Okay.
So barium, what is chemical formula for barium?
BR. What is it?
Are you sure?
Oh wait, no, that's bromine. It's BA, right?
Ba, that's right. Ba, and we know that Ba is a group 2 metal, so it has a +2 charge and it forms an ion. See, right, where is it? Right here. Okay, so it's a +2 charge. So
Okay.
then hydroxide, if I look at hydroxide on my polyatomic ion table, you see hydroxide?
Let me think. Wrong table.
Oh,
Hydroxide.
there you go, hydroxide right there.
Oh yeah. Okay. So it's
So,
OH negative.
yep. So it's OH negative. So how many, since we know that barium is going to be a 2 plus, how many OH negatives are we going to need? So barium is 2 plus,
And OH is what was it?
it's -1.
Negative one.
Yep, negative. OH negative, which is -1. So for it to add up to 0, we have 2 and then 1. So 2 minus 1,
Is one.
that's 1. So how many OHs will I need?
You need one. Well, you need two.
I'll need a total of 2.
Yeah.
So then when I write my chemical equation, I'm going to write OH, and then I'm going to put parentheses,
Parentheses. Okay.
2. Okay, so now this time, we're going to have a double displacement reaction because both of these are going to be ionic type compounds. So in one case, let's do this in green, we have sulfate, which is our negative ion. That's going to hook up with barium, right? We know sulfate is a 2 minus, and we know that barium's a 2 plus. So in that case, we're going to get barium sulfate, BaSO4, plus, and that's aqueous, plus, in the other case, since it's we're taking the hydrogens and the oxygens are the hydroxides, and put them together. So then if we have HOH, that's the same thing as saying, how many H's is that?
2. So H2O.
That's right. Okay, so we have H2O, and we're going to have 2 of them, right? Because that's a total of 4. Yep. Okay, so then everything else should be balanced out. Check to be sure. So we have 1 barium, 1 barium, 1 sulfate, 1 sulfate, 2 hydrogens, 4 hydrogens, so total 4 hydrogens, and 2 oxygens. Yep.
Okay.
Okay, so then that would be our chemical equation.
Oh, liquid, yeah.
And because water is liquid, right? Okay, so how many coefficients again?
1,
this case?
2, 3, 4, 5.
That's right. Okay. Our next one, we have lithium combined with oxygen to form lithium oxide.
That's Li.
Lithium plus,
Mm-hmm.
that's what that combined means,
Yeah.
oxygen. So what is oxygen? Is it monoatomic or is it diatomic? Have no fear of high school fear.
Okay. Is
Is
it
it
a diatomic?
diatomic? Yeah.
Yeah.
Okay. And then we're forming lithium oxide. Lithium, what group is lithium in?
The main group.
It's in the main group. Which one?
The first one.
Two. First one. So it's a group 1 metal. So
Mhm.
it's going to have what charge when it forms an ion?
Positive.
Okay. So it's just going to be a plus.
Mhm.
So, and then oxygen, when it forms an ion, what is it going to be?
Negative.
Okay. 1 negative, 2 negative, 3 negative.
Um,
It's right here. How far is it from being a noble gas?
2.
2. So then it's going to have a -2 charge.
Yeah.
Right?
Mm-hmm.
Okay. So now, if these are going to balance each other out, how many lithiums am I going to need?
2.
I'm going to need 2. Right? So then my chemical formula is going to be Li2O. And that would be a solid. Okay.
Okay.
That's a gas. And metals are solids, except for silver. Okay, so the coefficients, what is the coefficient for lithium? Oh, is this balanced first off?
Yeah.
It is?
Isn't it? Oh, no, 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 it's not. I was thinking the oxygen on the product side had the 2.
Okay, so oxygen has how many on my reactant side?
2.
And then on my product side?
It has 1.
Okay, and then the lithium.
It has 1 and 2.
Okay, so what do I need to do?
Multiply by 2.
Okay, the lithium on this side.
Yeah.
So then that gives me 2.
Mm-hmm.
Okay,
And then on the other side, the 2.
okay, so we put a 2 here. So then that would give me 2 oxygens, but then that gives me 4
Oh,
lithiums.
4. Mm-hmm.
So then I need to put a 4 here. So we'll erase that and put okay. So how many, what is the coefficient for lithium?
4.
Okay. Okay, number 36. So nitric acid, oh, that's an acid. So what do we know about acids?
Um, Hydrogen.
Okay, so we need hydrogen, and so we have H plus. Okay, so nitric, IC. So what do you think nitric is going to go with? So if we're going to replace that IC with what?
8.
8. Okay, so we have
Nitrate.
nitrate. So what is the
Nitrate.
chemical formula for nitrate?
Nitrate would be NO3.
Okay, what
3
charge?
minus.
That's right.
Negative.
It's negative. Okay, so then I have a positive and a negative. Doesn't that balance each other out?
Yeah.
Okay, so then I'm going to erase those charges since they're balanced. Because we don't put the charges on there. And
Mm-hmm.
always, since it's an acid, we're going to put AQ. And we're going to add potassium hydroxide. So potassium is what symbol?
K.
Okay. Oh, yes, please. Sorry. So then we have K and then hydroxide,
Is OH.
OH. K is going to be what charge?
Um, Positive.
Okay. And then hydroxide.
Negative.
Okay. And there's one of each. So they
Yeah.
balance each other out perfectly. So then I'm going to erase those charges because I
Okay.
know that they don't come with charges.
Mm-hmm.
They also told me it's a solution. So that's going to be AQ, right? In the aqueous solution.
Mm-hmm.
And then that's going to make, so again, this is going to be a double replacement reaction. Uh, right. So that's going to hook up with, let me use a different color.
Well, it's gonna be
H.
H2O.
It's going to be, yeah, it's going to make H2O. That's right. And that's, water is always a liquid,
Mm-hmm.
unless it's a gas or a solid. But
Is that gonna be potassium
that's right. Potassium
with that one?
nitrate
Nitrate. There you go.
plus. And you're always right. The positive always goes first. That's how I
Mm-hmm.
know students learn what they're supposed to learn. Okay, and that would be aqueous. Okay, is it balanced? We have one potassium, one potassium. We have 4 oxygens. We have 4 oxygens, and we
Mm-hmm.
have 2 hydrogens. 2 hydrogens.
2 hydrogen. Yeah. That's fine.
Okay,
Um,
place this down here. Okay, so then the question asks, it says, what is the sum of the coefficients then?
oh wait, it says what is the coefficient for potassium fluoride?
Oh,
Oh,
that's the
that's
one
the
down
next
here.
one. Oh, sorry. It's let me see. 1, 2, 3, 4.
Yep, that's right. 1, 2, 3, 4. That'll be the
Yeah.
sum. Okay. So when potassium contacts fluorine gas, potassium fluoride is formed. Right? A balanced chemical equation for the reaction. What is the potassium? What is the coefficient for potassium fluoride? Okay, so potassium we know is K.
Okay.
Fluorine gas
Solid.
have no fear of ice cold beer.
Wait, what's fluorine?
At our periodic table,
Oh, fluoride. Hold on.
fluorine,
Fluorine.
fluorine.
Uh-huh.
Okay, so F, how many?
Wait, where is it at? Oh, it's is it gonna be two?
That's right, because it's
Negative?
diatomic. That's right.
Yeah.
And we know it's a gas because they told us.
Mm-hmm.
And it's going to make potassium fluoride, right?
Mm-hmm.
Okay, so charge on potassium when it forms an ion,
Positive?
okay, and the charge on fluorine when it forms an ion,
Negative?
okay, 1, right? So
Mm-hmm.
then we know that they match up perfectly, so it's
Balance.
just F.
Okay.
Is that balanced?
No.
Okay, so then how many fluorines do we need?
Two.
Two. So we need 2 on this side.
Mm-hmm.
Okay, so then that would give me 2 fluorines and 2 potassiums.
Mm-hmm. So it's one, and so then you need two
Okay,
on the other one.
okay,
Okay.
now we're balanced. Okay, so what is the coefficient in front of the potassium fluoride?
What was it? Oh, potassium. Two.
2. Okay,
Mm-hmm.
okay, so ready for the next one.
Yes, sir.
I guess I should put the right answer up. Okay, so we have calcium nitrate and cobalt 2 fluoride solution reacts to form a precipitant. Identify the type of chemical reaction, predict the chemical reactants, and write a balanced chemical equation. Okay,
Okay.
so we have calcium, symbol for calcium,
Uh-huh. Ca.
Ca, okay. And that has what charge associated with it?
Positive.
How many?
Two.
2, okay. Okay, and then nitrate,
Nitrate is NO3 minus, negative charge.
okay. So then how many of those am I going to need to balance out my calcium?
Two.
2. Okay, so I'm going to write Ca parentheses NO3
Two.
2. And it's a solution. So anytime you see solution, it's AQ plus, and we have cobalt 2
Uh-huh.
fluoride. So what does that Roman numeral mean?
That there are two.
That's right. Not that there are 2, that it's what charge?
Oh, positive or
Positive
negative?
what? No, it's
Positive
positive.
two.
Positive 2, right? So
Yeah.
the Roman numeral always means that the ion is going to be a positive, whatever the Roman numeral is.
Yeah.
So case 2. And then fluoride, what is the charge on the fluoride?
Negative. One.
Okay. So then how many of fluorides do I need to balance out my cobalt?
Two.
Okay. Okay, and that's AQ because I said it's a solution.
Mhm.
Okay, so then that means, okay, now who's hooking up with who? Who's taking who home?
Um, it's a, is this a double replacement?
That's right. It is a double displacement or a double
Or
replacement.
yeah.
Yeah, you can
Uh,
use either one. They're both correct.
okay. So then, with calcium hook up with fluorine?
Right. So the calcium is going to hook up with fluoride. So we
Mhm.
have Ca. How many calcium? I mean, how many fluorides will I need to balance out the +2 charge of calcium?
Two.
And I think I'm trying to remember calcium fluoride. I think that's a solid. Yep.
So
Plus, and who else is hooking up with who?
the cobalt with the, what is it? Nitrate.
That's right. So what is the charge on the cobalt?
Negative. So the cobalt. Oh
The
no, the
cobalt.
cobalt it goes first because it's positive.
That's
And
right.
yeah, and then the other one.
And it's plus what?
Cobalt? Let me
Cobalt.
see.
What is it? Yeah, cobalt is plus what?
I don't know. Let me check.
Look on the board.
Look on the what? Right
Look
there.
on the
Oh, two
board.
plus.
That's right, because the Roman numerals are 2 plus. So,
Oh yeah, that's right. I was like, how did we even figure that out in the first place? But yeah, I forgot. The Roman numeral.
so then how many nitrates will I need to balance it out?
Two.
Sure. Anytime you have nitrates, like anything with nitrate, it's always going to remain aqueous.
Aqueous.
Yeah. So nitrate with something else is always going to be aqueous. Okay.
Okay.
Okay. Is it balanced? You
Mm,
have one cobalt. Let's write it out. Rather than trying to. So cobalt.
hmm
How many do we have on each side?
One.
And then product side.
One.
Okay. Calcium.
We have one on reactant and one on the product.
Okay. Fluorine.
We had two and two.
And then we're going to put the nitrates together, or everything with a
Oh
nitrate.
yeah. Uh-huh.
So how many do we have?
Two. Oh no, six. Sorry.
No, no, we're
No,
talking about the whole thing. So you're right, it's
oh
two.
yeah, it's two and two, right?
Yep, that's right, because we're
So
looking
it's
at
balanced.
outside the parentheses.
Yeah.
Okay, that worked out perfect.
Okay.
Okay, you ready for the next one? It says you
Yes.
have 85.80 grams of barium chloride pentahydrate. Determine the number of moles and the molecules of barium chloride pentahydrate.
Okay.
Okay, so we have 85.80 grams. Now, barium chloride pentahydrate. So
Mm-hmm.
barium chloride is what? What is the chemical formula for barium chloride?
It's BaCl, the dot, and then 5H2O.
Okay, dot 5H2O. Now, what is the charge on barium?
Barium is where is it at? It's positive. Is it two plus?
Positive. That's right, 2 plus. Yep. So since we know it's 2 plus, and chlorine is what charge?
Negative.
Negative what?
Is it three? No.
Are you sure? Where is it at on the periodic table?
Where is it? It is row 317.
Okay. How far is it from being a noble gas?
Oh, one.
Okay.
Sorry.
So remember, group 17s are always going to be a -1. So
Yeah.
these all are going to be -1.
Yeah.
Okay. Or okay. So in that case, we need how many to balance out our barium? Since these guys are going to be 2
Two.
plus. That's right. We're going to need 2 of them. Okay, so that's our chemical formula. So now we need to calculate its atomic mass. So I always like to do water first. Water is H2O. So that's 2 for the hydrogens. We have 2 hydrogens. We have 1 oxygen. So then that's 2 plus the oxygen is approximately 16. So isn't that about 18? Okay, so that's for my water. We have 5 times 18 because we have 5 of them. So that's what.
90.
Okay. Okay, and then we have our barium. Barium weighs 137.33. And then chloride, we have 2 of them. So we have 35.45 times 2. So add that together. 71. 70. 9 plus 1.33.
Is it 28.23?
208.23. And then if we add that 90 that we got for the waters. Okay. Let's see. Plus 90. So we have.
No, 98.23.
Yep. 298.23. And that's grams per mole.
Grams per mole.
Okay.
Okay.
So then what we'll do is we'll divide by the grams. So that's 298.23, and that's grams of my barium chloride. And then that's 1 mole. Okay, so and that's barium Cl2 dot H2O. Okay.
Okay.
So that's going to be equal.
Let me see.
To our number of moles.
0.80 divided by. Is it I got 0.287.
0.287. That's exactly what I got.
Okay.
And that's moles. So 0.2870 is because significant figures, 4 sig figs, right? Moles of barium chloride dot 5H2O. Okay, so then that would give me my moles. And then now we want molecules. So what do we need to multiply this by to get molecules?
0.28. So
There's a number. It sounds like avocado.
yeah, is it the avocado, the 6.22 times 10 to the, what was
That's right.
it?
The
Yeah,
23rd. Yep.
23rd. I was gonna say 10 to the 3, but I was like, that's too little.
Yep. Okay. So we're going to multiply that times avocado's number. So 1 mole, which is going to be on the bottom.
So then the avocado's number goes on the top right there, or the mole.
So yeah, so then avocado goes on top. So 6.022 times 10 to the 23rd. And that would be molecules.
Molecules.
Okay. Of barium fluoride, yeah. Pentahydrate. So then we'll get 0.287 times 6.022 EE23. So you're ending up with 1.728 times 10 to the 23rd molecules.
Molecules.
Yep. I ran out of, I hate when I do that.
Right. But it's to me too.
Okay. So that's number 39 for
Yes.
10 points.
All right.
Okay.
Put that one on the test. Well,
Yep.
on my test.
Okay. Ready for the next one?
Yes, sir.
Yeah. So the biggest thing is the key, let me tell you, the key components is nomenclature, right? If you notice, you have to name everything and write the chemical form. Either you have to name it or you have to write the chemical formulas.
Uh-huh.
You have to name it, you have to write the chemical formulas.
Right.
But nomenclature is going to be your big thing. So,
Okay.
okay.
All right.
Let's see. And our last question for the goal for that 100%. Okay, so this guy, this is called
Arsenic.
hypoarsenous acid. Okay, so now this is playing off of what we talked about arsenous, right? So arsenic. So
Yeah.
arsenic is in the same group as phosphorus, right?
Mhm.
So if we had phosphorus, right, then we know that it's going to be similar to that phosphate. So
Okay.
PO4, O4 is phosphate, right? And that
Right.
has a minus. Okay.
Uh-huh.
Now, since it's an acid, we know that we have to balance that out, right? So,
Yes.
but in this case, we're going to be working with arsenic, right? So that
Mm-hmm.
means the ASO4 3 minus. So this guy is, if it's 8, because this guy is called arsenate.
Mm-hmm.
Arsenate. Now, we know that because these guys are going to act very similar to each other since they're in the same group. The
Uh-huh.
the phosphorus and the arsenous.
Mm-hmm.
I mean arsenic. So it's going to form similar to what you get for phosphate, right? Now we know if it's 8, we're going to change it to ic.
Uh-huh.
Okay.
Yes.
So, but this is 8, right?
Yeah.
Now, our acid, if we look at the name of our acid,
Mm-hmm.
it's arsenis, O-U-S, right?
Yes.
And it also has a hypo as
Right.
well. Okay.
Mm-hmm.
So if we go down one, lose one oxygen, so it's AsO3, then that's going to be called, and that's 3 minus still, that's going to be called arsenite.
Oh, arsenite.
Okay. If
Okay.
we go down one more, we lose one more oxygen, that's going to be called hypoarsenite.
Oh, okay. It's still the 3 minus, right?
It's still going to be a 3 minus. The charge is going to stay the same. You're
Okay.
only going to lose oxygens.
The oxygens. Okay.
And so this guy's going to be called hypo. Okay, hypoarsenite.
Okay.
Okay, so then we have our hypo, we
Mhm.
have our ITE, right?
Yeah.
So then anytime that we see ITE, we go to that little table that we have. It says, I hate when I do that.
Right with the us.
That's right.
Os.
That's right. That's right. So the ite goes with the OUS, right?
Mhm.
So in that case, we're going to be using this guy, and we're going to balance it out with H plus. So how many H pluses am I going to need to balance out that -3 charge?
3.
3. So my chemical formula is going to be H3 AsO2. And I'm going to put AQ to remind me that it's an acid, because acids, these type of acids only take place in aqueous solutions.
Okay.
Okay. Okay. So the next one is tetraphosphorus. Tetra means what?
4.
So we have 4 phosphorus. So we never use it as a coefficient. So we know it's going to be a subscript. So it's
Mhm.
going to be 4. Dibromine. Di means what?
2. So
No
BR2.
bromine. Yeah, Br2. That's right. And then it says nona fluoride.
9. F. Is it F out or F? I
F.
get confused with that one all the time.
Yep. I know. It's easy too. And a lot of people make that mistake.
F.
Yep. So it's F. Yep. Okay. So then this was A.
This is B.
This is B.
Mhm.
Okay. So C, it's iron 4. So symbol for iron,
FE.
Fe. And then 4 means it's 4 plus. Okay. So I'm going to go ahead and put the 4 plus right now. And we'll
Okay.
fix it at the end. And then it's sulfite. So sulfate was SO4, 3 minus. So sulfite is going to be what?
SO3, 2 minus.
Not 2 minus.
No?
Oh, you're right. No, you're right. It's 2 minus. I screwed up because it's SO4, 2 minus up there. So you're right. It's 2 minus. My bad. So this is 2 minus, and then SO3, 2 minus. You're correct. So I have SO3, 2 minus. So then how many of these am I going to need to balance out that 4?
Can you just switch them? Like the 2 and the 4? Or no?
Well, because they're divisible by each other, you can't just switch it. Yeah.
Oh, no?
Nope.
Oh,
Because they're
so
divisible by
2?
each other. I'll need 2 of them. Yeah. So it's going to be Fe, SO,
SO3
yeah, SO3. Yeah, I almost did
and
SO4
2.
again.
Yeah.
Okay. And then it's how many hydrates?
5. So
5
5H2O, the dot 5H2O.
dot 5H2O. Okay. Okay, so then the next one, it says dihydrogen sulfur dioxide gas.
Okay, so it's H2.
D is H2.
Sulfur SO2. And then the gas, you have to put the G, huh?
That's right. That's it.
Okay.
And then E, it says calcium dichromate.
Um, E would be Ca.
So I'm going to look at my polyatomic ion table.
Yeah, chromate is CrO4 2 negative.
Okay, so it was the chromate you said, and it's Cr4 2 negative, but it says dichromate.
Chromate. Oh, so it's Cr207.
Oh, okay. So dichromate. Oh, right there. Cr207, 2 minus. Okay.
Minus. Uh-huh.
So then I have calcium is going to be what charge?
Positive.
Positive what?
2.
2 plus. So if
Yeah,
it's 2 plus, and then the dichromate is going to be 2 minus, so they match up perfectly.
they
So then
balance.
yeah. So I just
Okay.
need to write the chemical formula. So Cr2O7.